Hello, today I am going to create a program that will solve the chess module from the game Keep Talking and Nobody Explodes. Before we start talking about the module, we must go over how each piece moves since it's required knowledge to solve the module. The king is the easiest. They can move any adjacent piece around them, including corners. The rook can move up, down, left, or right. They can only pick one of those directions to move in for their turn, and continue going that direction until a piece is blocking their way. The bishop moves similar to the rook, but it moves diagonally instead. The queen is a mixture between the bishop and the rook. Finally, we have the knight. This piece can jump over other pieces, but it can only move in an L shape. Now that we've gotten that out of the way, let's look at the module.
All available experts, please report to room A9.
We can see a display with a number and letter on it with buttons that have the letters A through F and the numbers 1 through 6. Clicking on the numbers will change the display. The different displays represent coordinates that can go on this board that is found in the manual. We must figure out which pieces go on each coordinate and find the area each piece covers. If we've done it correctly, there will be one coordinate that isn't covered by any of the pieces. We must submit that coordinate into the module to solve it. Let's first find out what coordinates we have. We have A4, D6, F4, B1, A2, and C5. The order of these pieces matter, so it's important we go in order of what the module gives us. We know where the pieces go, now we have to figure out what the pieces are. The manual gives us a list of conditions that tell us what the pieces are. However, we can't go straight down the list since we must know what other pieces are before we start with the first one. Luckily, there is an order we can always use. We start with position 4 since it is always a rook. I'll make a mock-up board so we can visualize it better. Position 5 says the piece is a queen if it is white or a rook if it's black. Since position 5 is A2, it will be a queen. Next we'll look back at position 1. Since position 5 was a queen, position 1 is a king. Position 2 is a rook since the last digit of the serial number is odd. Position 3 is a queen if there are less than 2 rooks on the board. If not, then it's a king. We have 2 rooks, so it's a king. Lastly we have position 6. We have 1 queen and no knights, so position 6 is a knight. If we mark the places that each piece covers, we see that there is one square that isn't covered, C3. That is the piece that we must submit. If you find yourself having more than one uncovered area, you did something wrong. There should always be one. I'll go through the other examples quickly. The given positions are A2, F4, C1, E6, and D5. C1 is a rook, E3 is a rook, A2 is a bishop, F4 is a rook, C1 is a king, and D5 is a queen. Putting in the covered areas shows that A1 is the answer. The next set of pieces are C5, F1, C4, E1, F2, and A1. E1 is a rook, F2 is also a rook, C5 is a bishop, F1 is another rook, C4 is a king, and A1 is a queen. This leaves C6 open. Now we have A4, E2, D4, A1, D6, and F5. A1 is a rook, D6 is a rook, A4 is a bishop, E2 is another rook, D4 is a king, and F5 is a queen. The open spot is B4. Finally we have A6, D1, B3, E4, F6, and C6. E4 is a rook, F6 is a rook, A6 is a bishop, D1 is another rook, B3 is a king and C6 is a queen. The answer is A5.
So long, Bowser.
Let's start working on the GUI. I normally use choice boxes for the user to give feedback, but that would leave 36 different possibilities, which sounds like a pain to go through. Instead, I decided to have 6 text boxes that the user will type the coordinates in. There is no need to write the dash, and I foolproof the GUI so there can only be 2 characters in the text box. The first character has to be a letter, the second must be a number between 1 to 6 inclusively, and there can't be duplicate coordinates. The case of the letter doesn't matter, so the user can use lower or uppercase letters, or a mixture of both, and the program will work perfectly fine. There's nothing else to talk about for the GUI. Now we can actually start the solving process. I needed a way to keep track of the chessboard, so I decided to use a 6x6 2D array of characters. The period represents an open space, and I use the same letters for the pieces as I did in the example. The asterisk represents when a piece is covering that certain area. One of the challenges I faced was converting the coordinates the user gives into numbers the program can understand. I decided to use the ASCII values of each letter and number and subtract by certain values so they align with the 2D array. I also created a method that does the opposite so the user knows what the answer is and doesn't have to do any conversions themselves. I then had to figure out what pieces were what. I represented each piece as a character and followed the directions the manual gave us. Once the coordinates and pieces were all found, I then placed each piece on the board. I then had to create methods for each piece that would automatically cover the board. Some were easy, such as the king, while others took more work, like the knight and bishop. I called the respective cover area methods, and that should leave us with 1 period on the board. I then scan through the board to find the index of it, convert its coordinates with the method mentioned earlier, and tell the user. Let's see a demonstration of it.
All available experts, please report to room A9. Emergency cleared. All personnel, please return to your stations.
So long, Bowser.
Thank you for watching the video.